This is the brief on the mechanics of creating K-space in MRI. So, what is K-space? Well, it's basically the essential data matrix in magnetic resonance imaging. Think of it as the raw source data holding spatial frequencies, which, just means how quickly image intensity changes. Getting this K-space data acquisition right is how MRI systems really control the final image's resolution, contrast, and overall quality before it's even built. Okay, so we've got 3 key takeaways on how this actually works. First, let's think about the map itself. K-space isn't uniform. Different areas hold different kinds of information. Those inner, central rows, they're super important because they define the overall image contrast, kind of the big picture, the low spatial frequencies. But the outer edges, that's where you get the high spatial frequencies, all the fine details, the sharp lines and contours. That brings us to the second point. How do we actually navigate this map? It all comes down to magnetic field gradients. These gradients act like the system's accelerator and steering wheel, guiding where we go in K-space. Your position and how fast you move along a path is directly tied to how strong these gradients are and for how long they're switched on. Finally, MRI systems use different strategies, different paths to chart out K-space and collect the data you've got. Your standard grids, radial patterns, even fast spirals. But here's the thing. Whatever path you choose, it has to be done fast. Why? Because the signal you're measuring in K-space is really transient. It literally just flashes into existence after excitation and then decays pretty quickly. This forces a constant trade-off between getting the data fast and getting high-quality data. Ultimately, carefully controlling those magnetic field gradients, getting that timing and strength just right, that's absolutely crucial for tracing the right path through K-space to build a really precise diagnostic image.